Okay, everyone, welcome and thank you for coming to this, our keynote presenter right now. Um, we have Dr. St. Denis here, who's going to talk with us about the work she's doing in Earth Lab, and we invited her because we were particularly interested in understanding how practitioners, and in her case, she's a postdoc, how people are using different types of data from different sources to use in the type of modeling work that we're all doing this week. And I know that, well, she'll do some more introduction, but she particularly works with wildland fires, and I know we have some groups doing that right now. But this type of thought going into data from a lot of different sources, I know is relevant for all of our activities here. So thank you. I'll turn it over to St. Denis. Dr. St. Denis.
Um, Thank you, Diana, and thank you for the invitation to present today. As Diana mentioned, I'm a research scientist from the University of Colorado's Earth Lab, and I work as part of Jennifer Balch's fire research team. I also work in really close collaboration with the U.S. Forest Service's Wildfire Risk Management Science team, and I'm part of a collaboration with NC State that I'm going to talk about as well at the end of this talk. So a quick upfront disclaimer. My background is not fire science. My background is in the field of crisis informatics and computer science. But I joined Earth Lab in 2016, so I have roughly a decade of experience working alongside fire scientists. And just at a high level, what my work focuses on is taking the messy human observations coming from the ground, either from incident management teams or from communities impacted by wildfire, and developing new data sets and methods that can be used to pair that content with other sources such as remote sensing. So in today's talk, what I thought I would do is I work on a couple different key data products and techniques. I thought I'd focus on one of those data sets and talk about the evolution of how that's been developed and shaped by some of the projects I've been working on. And then shift gears and talk about some of the studies we've used the data set for and some of the high level results and kind of what my current research looks like and where it's going. So as most of you are well aware, the impacts of wildfires are steadily growing, particularly if you live in the Western United States, you're keenly aware of that. So wildfires are getting larger, faster, more destructive, and they're posing an ever increasing risk to our homes, things that we value in our health. So these growing impacts are due to a couple key factors. One of them is a consistently warming climate. And so drought conditions are drying out fuels. We have prolonged periods of higher temperatures. And consequently, we have longer fire seasons, so leading to more extreme fire and impactful wildfires. We also have, due to over 100 years of Smokey the Bear and an aggressive tactics for fighting fire and wildfires, we have this heavy buildup of fuels on the landscape and a cultural expectation that the right response to wildfire is to aggressively attack it. So this is just a picture to show you kind of that historical change. The photo on the left is much more of a historical norm. And then the one on the right is that forest more recently. So you can see how densely those trees are packed, leading to more intense wildfires. So one of the quotes I like is this wildfire paradox, which is the more we fight fire, the more fire we have to fight. The other thing is that we're increasingly putting our own selves in harm's way. Living in the forested areas is very appealing. So more and more that wildland urban interface is being developed, increasing our risk as well. And it's leading to some of these urban and suburban conflagrations that we've been seeing in recent years. This is just a list of a few of the examples for those of you locally the Marshall Fire. And I love this NOAA quote, La Nina, climate change, and bad luck led to that. So given this increasing complexity of wildfire, and all of these interrelated factors, where do we go from here? How do we start to tease apart the interdependency between these environmental changes, our response to that in terms of incident management, and then the growing impacts? So one of the data sets that I've worked on for a long time it's called the ICS 209 Plus, and it's based on the historic record of daily incident reporting, the ICS, and I'll talk more about this ICS 209 form. So an ICS 209 form is required by all levels of incident response as soon as something is large enough to require the use of an incident management team. And in wildfire, these reports are filled out by someone on the ground daily or for each operational period. And then they flow up to the geographic area coordination centers where they're used to manage the allocation of resources across all of the active fires at that moment. So what's great is these reports are a snapshot in time. They capture really valuable information about the characteristics of the hazard itself, the conditions where it's burning, all of the details about current incident response and what's needed for that incident response, and then also information about the threats and impacts of the fire. And none of these reports, these are really messy human data entry, and they were never intended for research use. But we've found that this is really the only place you can get this kind of temporal granularity, and some of the details, such as estimates of incident management, costs, things like structures threatened and destroyed. It's the only place you can get at this. So it was really attractive for us to try and wrangle this, which I've made essentially a big part of my job out of. So this is just a high-level description of the data set. So 209s are used on it's all hazards, so it's used on anything that requires use of an incident management team. But roughly 97% of the records are wildfire or fire related. Within that, we just added 2024, so there's over 40,000 wildfires, and we're over 250,000 of daily reports. The next hazard down in that is hurricanes, accounting for about 1%. And I'm working on finalizing the third release. We have a release that spans, our first release was published in 2020. It goes from 1999 to 2014. And then the second, which we published in 2023, made it to 2020. And then I'm working on a current version that now is over a quarter century of data that we're about to push out. And like I mentioned, it captures really valuable information at the daily level about the hazard itself. So the point of origin for the fire, for each report, its current acreage, its projected growth, what percent containment, key details about fire behavior, the fuel models and fuel conditions. It also captures detailed information about the incident management for that operational period. So complexity, current personnel and resources, an estimate of cost to date, which is the only place we've found that you can get estimates of suppression costs. There's details about the suppression strategies that are being used. And then really importantly, this form is used to lobby for additional resources. So they provide a lot of details around what's critically needed, any significant events and problems and planned actions. It also captures a lot of information about current conditions. I think I'm sort of repeating this here, but it captures a lot of information about the weather. I think somehow this captured the wrong data, sorry. So it captures all the environmental, like what are the fuel conditions, what is the weather, what's information about the terrain and contributing factors. It also captures some of the social information. So what is the underlying cause? So at this daily level, it just captures, is it human, lightning, or unknown? It also gives reports on the structures threatened, damaged, and destroyed. There's details captured about the evacuations that are currently underway. And it also captures information about injuries and fatalities. In the older version, it's just responder related, but in the current version, it captures civilian as well in there. And then importantly, it captures a lot of information about what's at risk, including things like infrastructure and neighborhoods, et cetera. And then really valuable is that these forms have a lot of narrative content captured across a bunch of different slots on the form. And so what I've done is cleaned and organized it around topics and set it up for use with large language models and text mining. And I've grouped it based on some of the key themes such as fire behavior, critical resources, values at threat, weather, damages. You can see kind of a high-level overview of that here. And like I mentioned, we published the first version in 2020, and that itself was a huge lift because the data set was not documented at all. It was contained in 3 different formats across 3 different iterations of the system. So we did a lot of work to align that to make it the cross comparison of the reporting possible. And when we published the first edition, really it was mostly about the daily situation reports. We had an all hazard version and a wildfire specific version. And then for wildfire, we also created this wildfire incident summary where we could then at the high level cluster information that belong together and give you all of those key statistics such as when the fire quit growing and what its maximum growth rate day was, et cetera, so that you could look at an incident in summary. And then we also use this wildfire incident summary to connect to a data set called the Fire Occurrence Database. And one thing I forgot to mention when I was talking about the ICS 209s is that the 209s are less than 2% of all fire in the US, which seems like a very insignificant amount, but they account for roughly 85% of suppression costs, and this is very conservative, and 95% of acreage burned each year. So this is the critical slice of the pie you want to analyze. So we linked to this fire occurrence database, which is curated by Karen Short from the Forest Service. And that is the much larger set of fires that were controlled under initial attack. And from that gives us access to all of the final fire reporting. So we know the final cause determination, the final acres, and it also connects to the fire perimeter because the FOD is linked to monitoring trends in burn severity, or MTBS, if you're familiar with that. So we published the first set in 2020, but we had to truncate it at 2014 because there were major corruption issues with the published data between 2015 and 17 that we weren't able to resolve. So we were able to go back and work with the Forest Service and fill in the gaps where we had to and get some updates on the corrupted files. And there was a lot more information in the most current release. So it was a major upgrade in terms of the information that we published. And then in addition to publishing that wildfire summary, there's something called a wildfire complex, which I'll talk about a little later. And doing analysis of wildfire complexes is pretty rare. Most research ignores them because it's really messy and hard to disentangle. But in the version 2.0, what I did was we manually worked to compile that information across different sources and publish that. So, and the other thing we did was, in addition to linking to MTBS, which gives you the overall outline of the fire, we developed a product in our lab called FIRED. It stands for Fire Events Delineated. And it gives you daily burn perimeters and all of the related stats. And so in the second version, we link that to FIRED. And then I worked with social scientist Catherine McConnell. She was using the data set to understand human migration patterns. And so we created an additional spatial version of the data set that aggregates at the county block and census tract level so that you can start to match some of the impacts with census data and other sources. So it gives you a spatial access to that data. So this is just an example. These are two fires I'm going to talk about shortly. And it shows you the outer outline is MTBS. And then you can see that fired gives you the daily burn and shows you where there are unburned areas, which isn't accessible via MTBS. And you can see the pattern of growth much more easily. And then this is just to give you a sense for the spatial aggregation that Katie worked on. This is a couple of, this is just the count aggregated at the county level. And you can see how heavily the reporting is concentrated on the Western US. So we're, like I mentioned, we're just getting ready to release version 3.0. And in this next release, a lot of this has been the outcome of ongoing collaborations. So the Forest Service publishes this IMSR data set, which is daily national reporting. And so we're folding and co-publishing that with the next release and linking it into the daily reporting. So you can see it gives you information about preparedness levels, which on a fire, it can tell you what the resource strain at that particular moment is. And it also gives you the fire's prioritization. So that IMSR report tells you for each region what is the highest priority. It gives you the priority, a numbered list of fire priorities. We also, as part of a project, just linked in integrated information from FEMS, or the Fire Environment Mapping System, which now adds details about fuel conditions and weather conditions at the daily level. We also, as part of Alan Arkowitz's work, we've linked in fire line effectiveness on fires where available, so you can see what percentage of lines held as part of the incident management. And then in this release, I've done a careful job of connecting with a system called Irwin, which in the Forest Service is the Irwin ID connects you to all the other reporting systems within the Forest Service. So we can start to pull out information from all sorts of different systems to build a better picture of what's happening. And then also in this release, I've added a much more detailed and robust reporting on wildfire complexes, and I'm going to talk to you a little bit about that. And then resources and personnel is huge and unwieldy, and we've done some work on that. And then the other thing is that this will now, like I mentioned before, it's all hazards, but we don't add much for the additional hazards. It's mostly wildfire focused, and we're adding some enhancements for that. So as I mentioned before, wildfire complexes are often excluded from research because they're really messy and hard to disentangle. This picture on the right is from a region during 2015, and it was NWCG, or the National Wildfire Coordinating Group's attempt to untangle and understand the relationship between when resources were strained and they folded complexes together and moved fires around to understand how that evolved over time. And so what's really unfortunate is if you eliminate wildfire complexes from your research, you ignore a really significant and important set of fires. So for example, you would ignore the August complex, which has over 50 member fires because it's just too difficult to disentangle. So that was something we added. This is just so I built a framework that allows me to maintain those daily reporting relationships and also maintain the most high level grouping based on, you can see on the top is a complex or 3 complexes that were joined together. But I still keep track of where a fire was in the individual original complex, and they're clustered under a complex grouping. And then, so that helped us make it possible to start doing some of that analysis and make sure you're not double counting things. The other thing we worked on is the resources table in the 209s captures all the details about both personnel and equipment, including aerial resources, but it's millions and millions of rows and very unwieldy. So I created a new view of it where I consolidated data based on the agency type. So are you state, local, or a particular federal agency such as USDA, the Interior, Department of Interior, et cetera. So it makes it, reduced it from millions to a couple 100,000 rows, and it's now possible to start doing analysis across that. So that's a project we're working on in our lab. And then resource type, I clustered the resource types so that you can see engines and crews and aerial all within one bucket. So shifting gear, that gives you a feel for the 209 data set and how it evolved over time. We've used this data set's getting used quite a bit in our lab. We used it in a in a paper that we published at the end of last year on fast fires, where we used information about daily fire growth and structures damaged and destroyed. And we were able to show that, so fast fires, we set a threshold of roughly a little over 4,000 acres or 1,624 hectares. So anything that had a single stay growth above that was considered a fast fire. We were able to show that half of the US ecoregions are being impacted by fast fires, and that threat is growing. And these fires accounted for roughly 78% of structures destroyed and 61% of suppression costs. So within that tiny important slice of data in the 209s, this is further narrowing in on the most important slice. I also worked on a study with the wildfire risk management team looking at what are termed cross-boundary fires. So these are fires that originate on federal land but eventually escape federal boundaries. So we use the 209 data set. You can see the visualization on the left where we were focused on lightning ignited fires that met a growth and duration criteria that escaped federal land. And we found that overall, less than 2% of wildfires ever escape. And when they do, they rarely destroy structures. But these are fires that are notoriously difficult in terms of the political backlash that they can generate, leading to really detrimental shifts in policy, such as a freezing on all fuel management strategies, so freezing of prescribed burns, and shifting things to full suppression. So this is just a short list of fires where that happened. And then this is a headline to give you just a sense for that narrative that emerges and this public idea from our long history of fire suppression that the Forest Service it's the Forest Service's fault when a fire escapes, and that there's either through negligence or intention this let burn. So now I'm going to shift gears to my pilot study. So as part of my doctoral research, I worked alongside incident management teams, and there were 2 fires in that cross-boundary study where I was actually on the fire helping the team on the ground. And I knew from that experience that there were very different, these 2 fires were very analogous to one another, but very different public outcomes. And because I was on the fire and we had interview results for these 2 fires and also lots of after action reporting for particularly the first fire, the Chetco Bar fire. So we wanted to see if the techniques that I was building to filter social media data would be able to pick up on that reported difference. So this is just to give you a feel for the similarities between these 2 fires. So they both started in the Rogue River Siskiyou National Forest in Oregon. They grew to approximately the same size. They had the same duration. Both destroyed structure, or only the Chetco destroyed structures. They both were fast fires, and they threatened the same communities just by their proximity to one another. So you can see on the lower left is the perimeter for the Chetco Bar fire, and the Klondike fires burned right up to that burn perimeter the following year. And we knew from after action reporting and our own knowledge that there was a huge management shift between the two fires. So they changed forest supervisor who took a very different approach to management, shifted away from the national chief's letter, and promoted, heavily communicated to the public that they were going to aggressively attack fires in the region. They, instead of having more of a monitor approach, they had a type 1 team, which is the highest complexity team, staged and ready to go from the start of the fire. There were also no competing events that were drawing public attention away, and they staffed, but they both occurred at times when resources were scarce. So they were under very similar conditions. So this is taking data from 209, where we looked at the top band. A is we computed the air quality surrounding the fire to look at the relationship that public response had to that. We also looked at fire growth, so you can see that in B. You can see the sharp rise on the Chetco Bar fire on the left, and then more steady but fairly aggressive growth on the Klondike fires. And then a difference in structural threat. So heavy onset of structural threat for Chetco, but for a very much shorter duration. Whereas on the Klondike fires, structures were threatened almost from the start, and they were threatened for 3 times as long. So a different sort of stress, but a stress nonetheless. And you can see on the bottom, that's the preparedness level derived from the IMSR data set. And you can see that during that intense period, they were both at PL5 and resources were scarce. This is the progression maps. So the MTBS perimeter on the outside in black, and then the fired perimeters. So you can see the difference. You can see the Chetco started and stayed small in remote wilderness at the start, and then made a significant run over a series of days, less than a week. And then on the right, you can see that the growth pattern, that fast initial growth on the Klondike fires heading towards communities. So it gives you a spatial feel for that information. And then the other thing that I work on is that I've built, using machine learning, I've built a classifier for organizing and filtering social media data. So what I've done is I organize content based on an individual's contributing role, which is different from how most techniques have been historically. And it allows us to then narrow our focus. So disaster events can generate millions of tweets. We use this on the Camp Fire, where we had, I think, 21 million tweets in a very short period of time. And the localized content that we're interested in is only about 4%. So it allowed us to narrow down and look at what happened at the community level on that fire. It also allows us to pinpoint emergency management communications. And so in this pilot study, we were interested in looking at the interplay between official messaging and community response. And although the filtering doesn't guarantee that you get localized content, it's heavily concentrated based on how we do it. It's heavily concentrated new information. So this is some of the social media analysis from the fire, and the top plot F is daily tweet volumes by contributor type. And you can see, and these correspond with the growth and threat phases, which makes sense. But what's really interesting in the Chetco daily is that you can see that there's this sharp rise when there was a growing threat, and there's an even stronger peak later on after that threat has more or less passed. And that was the part we were really interested in. And then the other thing that we did, the bottom plot takes just those local personalized tweets, and we code them for sentiment. So we have something that does this automatically, but we went through and manually labeled them based on a sentiment theme. And you can see that and so positive or neutral are above the x-axis and negative is below. And you can see that for Chetco, much more negative localized response. And then in particular, that sharp spike that happened later is related to a community that felt like there was an informational void and that nobody cared about them. And this is a backlash to the governor of Oregon visiting the Eagle Creek fire up near Portland, where they felt like people cared more than they did about this rural community. So we could see that. And then consistent with what we heard and what I experienced and we saw in the after action reporting, it was much more neutral on the Klondike fires. So there was some negative sentiment, mostly around the stressors of the fire, which you would expect, much more associated with information sharing because the updates were more readily available. And we saw that people were much better informed on this one. And so when we looked at the criticism, the highly critical content, we grouped it into a couple key themes. So one that I mentioned that I've never seen or never seen to this degree is a reflection of this informational void, this public engagement failure. The second is this targeting fire mismanagement and this let burn narrative that I talked about. And then a feeling that the right resources weren't being assigned to the fire. And then there was also a significant chunk around land management and ecological themes. And this echoed what the interview findings of Noelle and her team, Brandon Noelle and her team found in prior studies. So just to give you a couple of examples of this, this is that what about us signal that we saw. Often it was directed towards media, public officials, or the fire teams, or also to get attention of celebrities or influencers. And this is an example tweet, just showing you kind of that sentiment. It's a reaction. This is one that's a reaction to Governor Kate Brown's visit to the Eagle Creek fire. And then these are some examples of that mismanagement and the let burn narrative. And we found that a lot of these centered around clever memes. So this is Forest Service. The more we burn, the more we earn, which gets at this idea that there's a profit motive involved. And this was a very palpable stress level on the Chetco fire. There's also a lot of belief that that the right resources weren't being assigned to the fire. There was a media article from a big air tanker company that essentially asserted that they could just fly the air. They were being prevented from flying an air tanker over these fires. They could just put it out, which gets at some of the communication challenges around fire management and resource use. And then this is some examples of some of the ecological and land management themes, a lot of times motivated by the ranching community or other more conservative interests. So that gives you a feel for, we used that on the pilot study, and what we wanted to do was to see if the techniques I'd built with social media could be used to do historical analysis. I have a repository of over 100 of the most destructive fires in our history, starting at about 2012. And then the other, which is is really interesting to me, is could we build a tool that we could use in near real time to look at fires that are being managed by complex incident management teams and pick up on that negative or that heavy community signal in real time and intervene and better serve the needs of the community and address it rather than waiting until it triggers a backlash. And that's actually something, so this gives you a feel for, like we did in the study, taking information from the daily national situation report, information from the 209s, and we're currently taking information from Blue Sky and then running it through the filters and doing for all the fires on the IMSR that have a complex incident management team, we're using it as a gauge moving towards potential. And we use that this summer. We have a fire watch where we're following and looking for. I'm part of Brandon Noel's interview team, and they don't want to deploy and do interviews on a fire that's not going to be interesting because they can only go out on a select few. And so using my techniques, we were able to pinpoint. We went out on our first fire last week, which was the Burdoin fire, which on the surface might not have seemed interesting, but we were able to pick up on a really interesting signal online. And so we used that. So that was pretty promising. So this is a photo from last week from the Burdoin and Snyder Canyon fires. And then that's it. So if anybody has any questions, happy to answer.
Oh, hello. Thank you very much for the impressive presentation. So I'm just have a quick question on the Chetco and Klondike fire. So I was just curious, to what degree do you believe that the fact that Chetco fire happens first and Klondike happens second causes the difference in their influences both naturally and socially?
Lisanne, if you could speak in the
Sorry.
microphone, it'll help thanks.
We knew there was a very strong relationship between the two. The strong political backlash from Chetco led to a very different approach. They went into the teams that were interviewed referred to it as the Chetco effect, which is that nobody wanted to see that happen again. And so they went into the following season with one of the most skilled type 1 teams waiting in the wings, essentially. That was who I was on the fire at the tail end on Chetco, and that's who came in first on the Klondike fires. And they hit it very strongly with public engagement and cooperator engagement. That's the other thing I might not have mentioned, is that there was a breakdown of communication and coordination with local cooperators as well that was part of the failure. And the shift in fire chief, he came in recognizing that any of these fires that are lightning ignited could blow up. So we're going to make sure we have a coordinated communication across all fires that pose any sort of risk. So I think there were a lot of lessons learned.
Other questions?
Hello, thank you for presentation. I have a question about the fast-growing fire. How do you define the fast-growing fires? Does it have does it have a threshold to define the fast-growing fire?
Yeah, let me see if I can go back. Right here somewhere. Hang on. Oops. So yeah, we did some analysis and set the threshold at roughly 4,000, little over 4,000 acres of single days growth.
Because it's mostly depend on the weather condition. I mean, the wind direction and everything. How do you find that threshold? You know, I'm interested in that.
So I didn't do some of that analysis. I mostly supported the data underneath, but they did some cluster analysis and some other analysis methods to pinpoint where's the right inflection point to say this is fast. And what happens is that these fires grow so fast, it's hard to get a team in place and positioned and ready to do anything more than evacuation on these fast growing events.
Thank you very much. It's really interesting work. Actually, it's connected to what we're trying to do here on both the physical side as well as the social side. You kind of balanced so well from your case studies. I had a very basic question. You mentioned the multiple data sets the very, I think, important one, cutting
Sorry.
important, oh, your phone?
Yeah, it's my phone.
Okay.
I'm going to ignore it, but sorry about the ringing.
As multiple decades, but also the unique data sets from your own case study. So my question is, how do we access your data? Is the data already online available?
Version 2.0 is published on Nature Scientific Data.
Okay.
So if you Google all hazards data set and look for the one that goes through 2020, and we're in the final stages of the most recent version. So I'm hoping to have that pushed out by the end of the year.
Mm-hmm.
So
let me ask a question for any of the teams working on the wildfire analysis or modeling. Could I ask some of you to get that Nature Scientific Data to the iGuide platform? All right, any volunteer? Are confident?
we would love to see it
All right.
used.
Yeah. All right. So Manju has stepped up. Yeah, we'll have your data on our iGuide platform, and we also include publications you might have cited, I'm sure.
Yeah, I can send you the publications. There's also, you should consider the fire line effectiveness and the IMSR data set that are also published in Nature Scientific Data.
Yeah.
And I can send the references for that.
Thank you. That will be so much appreciated, right? It's very related to what we're trying to study here. Thank you. Thank you.
Sure.
Yeah. I'll give you a card for us to get connected after this.
Sounds good. That's been one of the challenges is put so much energy into building the data set, but it's hard to really get the word out.
We would like to help.
Thank you.
Okay. Any final questions? Yes, Stephen Baker. And then after that, thanks to all for, thank you, Dr. St. Denis, for your presentation. And we'll be moving into teamwork after this question.
Thank you. I read a terrifying book last year called Fire Weather, which is about the camp. And one of the things that groups are doing this week is looking at, some of the groups are looking at the difference between perceptions and actual risk. And I wonder whether you have any insight as you're studying people's reactions to fires about their assumptions about fire risks and the relationship between those things.
So we have we have a member of our lab that focuses on risk modeling, Virginia Iglesias. She'd be a good person to reach out to. But my own personal experience working with communities, I think like the fire that I was on this past week is that I think people are really being blindsided by not thinking, we haven't, like on the north side of the Columbia River Gorge, they felt like we have fires, but nothing too bad. Nobody saw it coming, essentially. And I would say that's also really true of the Marshall Fire. Nobody saw that happening. So I think there's this gap between risk and perceptions. That's really palpable. And how do you bridge that and help people? It's part of what I think our risk modeling effort is surrounding.
Hi, thanks for your great presentation. I have a quick question related to the social data that you use for your work. I know that there are kind of a lot of noise in this kind of data set. So I'm wondering that what kind of challenge did you face when you're working with this data? And do you have a special tips or tricks for handling this kind of noise?
Great question. Thank you. I didn't have enough time to really go into that in detail, but what motivated it's notoriously noisy. So we didn't want to spend time sifting through to find the content we were interested in. And I built the techniques that I have based on an experience that I had in 2014 on the Carlton complex, that I was supporting the team on the ground and it burnt through 2 communities. And the public information officer on that fire said, in the thick of it, I appreciate all the work that you do. So at the end of the day, I would wrangle and provide reports that they would use going into the morning briefing, but we couldn't get through it fast enough to tell her what she needed to know in the moment. And so the approach I took was being able to pick out that local signal. So that ends up being about 4% of the data collected. Pretty consistently, doesn't matter. We found across all fires that that's roughly what it is. And and then being able to the other important piece is what was communicated to understand that relationship. So the way we organize the content gives us both sides of that conversation, which is more, and then combining it with the incident data helps us understand it's a complex picture, and being able to piece together all the things that are contributing to that is actually pretty important.
Hey, thanks. Yeah, really wonderful. I just had a quick question because you mentioned 2% of the fires were in the reports, basically, but it covers the largest extremes. So right away, I'm interested in the other 98%, just because I think it gives us
Right.
so much grounding in maybe the physics that we're starting to think about. Is there good data sets that cover all of that?
Yeah, that's actually when I mentioned the FOD and our linkage to the fire occurrence database. That's published by Karen Short. And Karen Short and I co-published the 209 data, which is kind of this nice collaboration because I have the wrangling skills, she has the inside information, and then she curates the FOD, which is that really important 98%. So where are our successes? What are the conditions where we are able to address fire?
Super beautiful. I mean, I could imagine us overlaying other data sets like other models of biodiversity and terrain maps and stuff like this. But I assume those data sets have latitude, longitude, timestamps.
And we work very hard on cleaning that point of origin data.
I think we'll have to put that to use. So thanks.
All right. Yes. Thought we were going to be at the end, but thanks, Lisa. Do you have a few more minutes for a question?
Oh, no problem.
Hi, thank you. So just a quick question about like also the social data, especially from the social media. And I wonder whether there were any kind of significant indicator that could help or any unique pattern in the social media report that distinguish fast spread fire from others at early stage.
So that's part of why we have this huge repository that we want to run the process over and look at what's the signal look like for these different, we call them fire archetypes. Where do we see different types of social signals? And so we're moving towards that. And based on my experience, you see when people in a fast growing fire, stress is very high. And if people don't have the information they feel they need to assess their risk, you're going to see, or if they don't feel like they're getting the attention they need, you'll see this strong negative signal. Very strong relationship, I would say.
All right. Well, thank you very much again for this presentation. And I welcome those of you with other questions for Lise we can follow up on email with her. I'll share her contact information. And anything from any of the other iGuide folks until right before we turn people over to their teamwork again? Xiaowen, Anand. Okay, it's time to work. All right, thanks everyone. We'll talk to you soon.